Hi there, welcome to my channel Mandu to Fundo. In this video, I'm going to discuss about the solution to grouping the anagrams. Let's look at the problem description. We are given an array of strings, strs, and we have to group the anagrams in that array together. Let's take a look at an example 1. So in this, the string array is eat, tea, tan, ate, nat, and bat. So here, eat, tea, and ate are anagram. So they're all grouped together. And tan and nat is anagram, so nat and tan are grouped together. Bat is only one word, so that is grouped in a single list, and all the three lists are put in the outer list. The array length is ranging from 1 to 10,000, and the length of the string is ranging from 0 to 100, and the string each contains only the lowercase letters. Let's look at the approach to solve this problem. So we have this input array of strings, and the expected output is a nested array with each index contains an array that has all the words which are anagrams. EAT, TE, ATE all forming the anagrams. Tan and nat forms anagram. There is only one word bat, so it is in the second index of that outer list. We can use the hash map to solve this problem. In order to group these words together in a same array, we need to remember the index of these arrays in the outer list. Okay, and then we need to come up with a key which give an index 0 for all these words. How can we do that? So one way is, if we sort all the characters in this word in a non-decreasing order, we get AET. Same way, if we sort this word, letters in this word in a non-decreasing order, it also forms AET. Same case for this word as well, AET. So whenever we see a word, we sort that letters in that word in non-decreasing order and check whether there is an entry in the outmap. If there is no entry, then we add that entry with the global index. This basically keep track of how many unique anagrams we have seen so far. So when we start, initially it is 0. So we put index 0. That is the index for that word in the outer list. If we see this word, for example, when we process the word T and we sort that letters, we have already an entry. So immediately we can use this index and add that word into the array present in that index. We maintain a global variable to keep track of the unique anagram in the input list. So how do we determine whether it is a unique? If after sorting the letters in that word and we make a lookup in the outmap, if it is not present there, that means we are seeing a new anagram word. So whenever a new anagram is seen in the input list, add a new list to the output list and add an entry in the outmap, and then increment this global index for the next unique anagram in this out list. If the input string has an anagram present in the outmap, for example in the case of when we process the second one, we already have an entry, so we pick up this index and add this word T to this list. We keep repeating that process until we process all the elements in that array. Finally, we get the anagrams grouped together. Let's look at the flowchart. Input for this procedure is an array of string. First we initialize the global index and then the out list and then outmap data structures. Next we check whether the input array is an empty. Then we immediately returning the empty out list. If it has an element, then we loop through that all the elements in that array. We check whether all the elements are processed in that array. If yes, we come out and return the out list. If there are pending strings to be processed, then first what we do, sort the characters in the string str in ascending order and use that as a key in the out map. And then we look up that key in the out map data structure. If it is not present, that means this is a new anagram. So we create a new slice of string str and add it to the out list. And then add that key to the out map data structures and increment the global index as its value. And then increment the, so next we add that key to the out map data structure and then the current global index as its value. Then we increment the global index variable. If there is an already existing one, then the out map data structure will have an entry for that. So from there we can get an index for that anagrams in the out list and add that str to that list. We keep repeating that until we process all the elements in the input array. Once that is done, finally we come out and return that nested list. Let's move on to coding. First I initialize the out list, which is a slice of string, and then I check if the input string array is empty, then I return the empty out list. Otherwise I initialize the out map data structure, which is a map of string to int, and then initialize the global index to 0. Then I iterate over the input string array. For each string, the characters are sorted in non-decreasing order so that we get a key for each unique anagram. So we are sorting here. Once we generate the key string, then I look up the out map whether there is an entry for that key string. If there is no entry, then I will create one with the current global index as the value for that entry. Next I create a new slice of string with only the str string in it and add that slice to the out list. And then I increment the global index. If there is an entry present in the out map, then I simply take that value as index into the out list and add the current word into that list. Finally, I return the out list. Next, I am going to run the test cases. The tests passed. Next, I am going to submit this program. Cool, this program is accepted. Next, I am going to do the code walkthrough with sample input. We have the input array with 6 elements in it, and the expected output is the anagrams are grouped together, each array. First we create the empty out list, and then the out map is empty and the global index is set to 0. Next we iterate over the input string array. Okay, so in the iteration 0 we see the string EAT. Okay, so first thing what we do, we sort the characters in that string in a non-decreasing order, and we get the key str which will be AET. After sorting we get a string AET. Then we check that there is an entry for the AET in the out map. There is nothing, so we add that entry and with the current global index 0 as the index into the out list. Okay, and then next we add a slice of string with only the str as the only word in it, and add that list to the outer list. Then we add an entry for that in the outmap data structure, and then we increment the global index. Okay, so at the end of the iteration 0 we see this, the global IDX point to this. The iteration 1 we have a word TEA. After sorting this word we get AET, and there is an entry in the out map, so we simply pick up the IDX value which is present in that entry and add that string into an array present at index 0 in the outer list. So we see EAT and TEA. Same thing, the next word is tan. So this is a new word. We after sorting we have A and T. So in this out map there is no entry for that key. So that means we are seeing a new word. So we add that entry in the out map. Then we create a slice with a single string in it and add it to the outer list at index 1. Then we process the next word ATE. After sorting we get AET where there is an entry already exists. So we add the ATE word into a slice present at index 0 in the outer list. Next we see NAT. After sorting A and T, there is an entry there. So we pick up this index and add the word NAT to the slice present at index 1. Same way BAT, this is a new, so we add an entry with an index 2 and we create a new slice with that only the word. So finally we get the expected output. Next I am going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. So we have 6 strings in the input array, and so let's see how many times this for loop has to run. It has to process all the words, so it has to run n times, which is the number of elements in the input array. And then we have to, each iteration we have to sort the characters present in each word, that is n log n times. The complexity of that sorting is n log n. So overall the runtime complexity, the time complexity is n times n log n, which is approximately order of n squared. And with respect to the space complexity, we have to return the out list in such a way that they are all the anagrams are grouped together. So it has to have a space as many number of strings present in the input array. So in addition to that, we need to have a space for the out map to keep track of the index in the out list. So the overall space complexity is order of n. Thanks for watching this video. Have a great day.